and then let me restart it, okay? Because recording is very important for revision purpose. So in this class, we are going to start with exercise 9.1, question number 13. Okay, if you have the textbook already with you, I have read the question as well. An observer from the top of a 75-meter high lighthouse. So an observer is at the top of a lighthouse. Suppose AB is the lighthouse. So observer is at the top of the lighthouse and the height of the lighthouse is 75 meters. All right. Now, from the eye of the observer, we always need to draw a straight line. From the eye of the observer, we always need to draw a straight line. That straight line will be known as the horizontal line. Is it okay? Now, what is this observer doing? This observer is looking down at the two ships. Is it okay? Now, what is the position of the two ships? The two ships are on the same side of the lighthouse. If this is the lighthouse, the two ships are on the same side, both of them. Okay? One of the ship is behind the other. Okay, one of the ship is behind the other. So, observer is at the top of the lighthouse. From the observer eye, we always draw a straight line known as the horizontal line. And this observer is looking down at the two ships. Those two ships are on the same side of the lighthouse, one exactly behind the other. So let's say that if C is the position of the first ship, then just behind C, there is another ship. So one of the ship is exactly behind the other on the same side of the lighthouse. All right? With an angle of depression 30 degree and 45 degree respectively. So this observer, he is looking down at the first ship. He's looking down at the first ship with an angle of depression. The bigger angle is given to be 45 degree. The bigger angle is given to be 45 degree. Okay. And at the same time again, the observer is looking down at the second ship. This observer, he is looking down again at the other ship. Okay. He's looking down at the second ship. So this is here. He's looking down at the second ship. So here is your B. With an angle of depression, this time now 30 degrees. Angle of depression means angle between the horizontal line and the line of sight when the observer is looking down, okay? So if the observer is at the top of the lighthouse, from the observer eye, we always draw a straight line, horizontal line. The observer is looking down at this ship, which is at C position. Then AC is the line of sight. AX is your horizontal line. Angle between the horizontal line and the line of sight, angle of depression, right? In the second case also, this is the horizontal line. This time the observer is looking down at the other ship. So AD is the line of sight. So angle between the horizontal line and the line of sight will be the angle of depression, which is equal to 30 degrees. Are you following me? Yes. Now let's complete the figure by joining this BD. So the figure gets completed by joining BD. Now we know that lighthouse will always stand perpendicular to the ground, perpendicular to the seashore. Is it okay? Now class, you see, this angle is 45 degree. This angle is 45 degree. These are parallel lines. AX and BD are parallel lines. This is the transversal. These 2 parallel lines. This is the transversal. then this angle and this angle are equal. Why? Here, angle 1 and angle 2. Angle 1 is equal to angle 2. Why is that? Can anyone comment here? Why angle 1 is equal to angle 2? Let me repeat. Two parallel lines. This is the transversal. A line which connects two parallel lines is known as your transversal. Then these two angles will be equal. Angle 1 and angle 2 will be equal. Why is it so? I have only 2 comments out of 100 students. Yes, only 2 students commented. Or 3 students. 4, 5, 6. Okay. Many commented, but only one of you is correct. Imti Sangam Rongomer. Yes. It's because of not just alternate angles, but it's alternate interior angles. Alternate can be exterior angles, alternate can be interior. In this case, this is alternate interior angles. Why? Because inside the line, so interior. Okay, there are alternate exterior angles as well, but here in this case, we have alternate interior angles. Okay, thank you for your comments. All right then. So due to alternate interior angles, just like this case, see, AX and BD are parallel. AC is the transversal. Then this angle would be equal to this angle. So if this angle is 45, this angle will also be 45 degrees. Why? Because they are alternate interior angles. The same way, again, AX and BD are parallel. This time AD is the transversal. AD is the transversal. Then this angle would be equal. Just come down to the straight line of this transversal. This is 30 degree. Then this angle will be also 30 degree. Why? Due to alternate interior angles. Same reason, okay? So our aim is to find the distance between the ships. C and D are the position of two ships. C and D are the position of two ships. So the distance between the two ships will be given by CD. That is our aim. That is our aim. Now, how to find this CD? Very simple. How to find out this CD? Very simple. First, you need to find out BD. First, you need to find out BD from the bigger right triangle. Okay, you need to find out BD first. And from BD, we subtract BC. We subtract BC. Then we get CD, which is the distance between the two ships. All right? From the bigger right triangle, we find out BD and we subtract BC, which can be obtained from the smaller right triangle. So BC minus, or BD minus BC gives us CD, which is the required distance between the two ships. All right. So our objective is to find out distance between the ships. So let me write down the objective here. So let CD be the distance between the two ships. Now let me start from the smaller right triangle. Your smaller right triangle is ABC. ABC is your smaller right triangle. Your angle theta is given to be 45 degree. And from this right triangle, we want BC, which is the adjacent side, and the opposite side is given. Okay, from this smaller right triangle, we require BC, the adjacent side, and the opposite side is given. So you need to think of a trigonometric ratio which involves the opposite side and the adjacent side. Class, can you guess which trigonometric ratio involves the adjacent side and the opposite side? Okay, 2 comments. Cot or tan. Cot or tan, not sine, okay? Mulungse posted it's like sine, no? Sine means Opposite side upon the hypotenuse. Here, hypotenuse has no role to play. Okay? Yes, we do not require hypotenuse here. So, in this smaller right triangle, we require BC, which is your adjacent side, and opposite side is given. So, a trigonometric ratio which involves opposite side and adjacent side is either tan theta or cot theta. So, in right triangle, ABC, angle is 45. So, theta is 45. So, tan theta means side opposite to angle theta upon side adjacent to angle theta. The value of tan 45 is 1. AB is 75 meters. BC is unknown. So if you cross multiply this relation, we obtain BC as 75 meters. So BC is obtained. Now our aim is to find out BD first. BD as well. How do we obtain BD? From which right triangle we will obtain BD? BD can be obtained from which right triangle? The bigger right triangle ABD. From the bigger right triangle ABD, using an angle of 30 degree, we can obtain BD. All right, class. Okay, so we go for the bigger right triangle in order to obtain BD. In right triangle ABD, your angle is 30 degree. So tan theta, which is 30 degree, tan theta means opposite side, that is AB, upon the adjacent side BD. For the bigger right triangle, your adjacent side is your BD. The value of tan 30 degrees is 1 upon square root of 3. AB is known to us, which is 75 meters, upon BD. BD is unknown, so if you cross multiply, your BD is obtained as 75 times root 3 meters, square root of 3 meters. Our objective is to find out CD. That's our objective, which represents distance between the ships. So CD means from BD, BD we subtract BC. Your BD is 75 square root of 3 meters. Your BC is 75 meters. 75 times root 3 is an irrational number, whereas this 75 is a rational number. We cannot subtract an irrational and rational number. We cannot do that. So what we do is we need to take some common terms from both. So we have 75 in common. If you take 75 as common, from the first term we have only square root of 3. From the second term we have 1. So this value gives us the distance between the two ships. Suppose you want to get a more precise answer, then you need to substitute the value of square root of 3 as 1.73. Then in that case, 75 times square root of 3 means 1.73 minus 1 meter. That is 75 times 1.73 minus 1, 0.73 meters. So you multiply the given two quantities. Then we get the exact distance between the two ships. So even if you stop your answer over here, or even if you get this answer, okay, you are going to get full marks in both the cases. All right? Yes. Plus, you can take some time copying it down. Okay, 2 minutes for copying it down, for noting it down. Today we have the maximum students coming live, 119 altogether. Okay. Plus, if you're done, some of you are commenting, sir, I can hear you. I can hear you, but can't see you. See, if you can hear me, but you cannot see me, then I think you have some problem with the network, okay? That we cannot help. So if you're done, okay, since you're done, so we'll be moving on with the next question, that is question number 14. A figure has been provided in the question as well. Okay. One of the most difficult question of this exercise is question number 14. So I'm going to remove this. So let's move on with question number 14. Figure is given, which makes things easier. Okay. If the figure is given in any question, it makes things easier. But let's see how to work out with this problem with the given figure and with the given conditions. Let's see. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. Okay, so the height of the girl is 1.2 meter. Okay, so a girl, she spots a balloon. Balloon is flying high up in the sky, and the height of the balloon from the ground is given to be 88.2 meters. Okay, height of the balloon from the ground. So I'm going to draw that. So a girl, she's 1.2 meters tall. So this is your girl. Not your girl, the given girl, okay? So AB is the girl, the given girl, okay? Who is 1.2 meters tall. All right? What is she doing? She's looking at a balloon, okay? She spots a balloon. High up in the sky, she spots a balloon. Suppose she spots the balloon right at sea, okay? And the height of this balloon from the ground is 88.2 meters. Balloon is flying at sea. Initially, the balloon is at sea, so the balloon is at a height of the balloon. Suppose CD is the height of the balloon. Okay? So this distance is 88.2 meters. Balloon is high way up in the sky. Okay, height of the balloon from the ground, 88.2 meters. Now she's looking up at the balloon. Now see, where is the girl? Where is the eye of the girl? At A or at B? At A or at B? The eye of the observer is at A, right? A is the height of the girl. Okay, so A is the point, okay, where her eye is located. So I told you, always from the eye of the observer, we always need to draw a straight line, right? Parallel to the surface of the ground. That straight line would be the horizontal line. All right? From the eye of the observer, we always need to draw a straight line. This straight line would be known as the horizontal line. So this is your horizontal line. So when the girl looks up at the balloon, Now this girl, she's looking up at the balloon. She's going to look up at the balloon. My line is not straight. So the girl is looking up at the balloon, right? Let me do it straight. Yeah. Yeah. The girl looks up at the balloon. So from the eye of the observer, you always draw a straight line, the horizontal line, and you draw another line connecting the observer eye and the object line of sight. Angle between them is the angle of elevation. So in this case, the angle of elevation is given to be 60 degrees. The angle of elevation is given to be 60 degrees. Are you following that? All right? Yes. Now, after some time, the angle of elevation reduces to 30 degrees. See, at first the balloon was at position C. The balloon is flying. Okay, the balloon is flying horizontally. The balloon is flying. So every second, the balloon is going to change its position. All right, every second, the balloon is going to change its position. So initially, at first, when the observer looks up at the balloon, the angle of elevation is 60 degrees. After few seconds, as she looks up, the balloon will change its position. Correct? The balloon will change its position. The balloon is not standing idle. The balloon is flying. The balloon is moving. So after a few seconds, the balloon changes its position. Say C dash now. C dash is the new position of the balloon. So when after the balloon changes its position, when the observer looks up now, this time the angle of elevation decreases to 30 degrees. All right? Yes. So when the observer looks up, after some seconds, okay, initially when she first spots the balloon, other than the angle of elevation was 60 degrees, where the balloon is at C initially. After some time, after a few seconds, the balloon changes its position. The balloon moves from C to C dash. In that case, when the observer looked up, the angle of elevation decreased. Now it's equal to 30 degrees. Okay? One of the most difficult question, okay, of this exercise. I'm drawing the line of sight. I'm drawing the line of sight here, okay? So this is your line of sight. This is the line of sight. This is your horizontal line. This is the line of sight. This time, the angle of elevation decreases. Now it is equal to 30 degrees. Are you following me? Height of the balloon from the ground will always remain the same, right? The balloon is flying horizontally. Hey, just say that this. What should I put? Okay, let me bring a balloon. Now, see, this is your balloon, okay? So, this balloon, okay, it is flying horizontally. The balloon is not flying in this way. The balloon is not flying in this way. If this is the balloon, at first it was at C, the balloon is just flying straight horizontally. Okay? Now, if the balloon flies horizontally, the distance of the balloon from the ground will always remain the same. Height of the balloon from the ground will always remain the same. Okay? This is the ground level. This is your ground. Let me draw the ground. This is the ground level. Your ground level. This is your ground. This is the ground, right? So the height of the balloon from the ground will remain the same. How much was that? 88.2 meters. So height of the balloon from the ground will remain the same. So C dash, D dash, this point is D dash. So this height is 88.2 meters still. Height of the balloon from the ground did not change. Even the balloon changes its position. Why? Because the balloon is flying horizontally. Okay, are you following this? Huh? If you are following with the figure, then I think calculation would not be difficult. Okay. So this height, this total height, yeah, total height is 88.2 meters. This one is total height, no? It's 88.2 meters, still the same over here, okay? Now let me complete the figure. Let me complete the figure like this. Okay. So A, B, C, D, C dash, D dash. Let me give this point as E, and let me give this point as F. This point is E, okay, and this point is F. Now you say, class, we want to find out distance traveled by the balloon. C is the initial position of the balloon. C dash is the final position of the balloon. Distance between C is the initial position of the balloon. C dash is the final position of the balloon. So distance between the initial position and the final position will give you the distance traveled by the balloon, right? Suppose initially you are at point X. After walking for some distance, you reached another point Y. Then X is your initial position, Y is your final position. Then distance between the initial position and the final position gives you the distance traveled by you, by an object. Is it all right? Yes. Okay. Now, what I'm going to do is, here, C dash, distance between C and C dash gives the distance traveled by the balloon. But C dash, okay, is same as EF, right? Finding C dash will be same as finding EF. Is it okay? Yeah. So distance traveled by the balloon would be given by either C dash or EF. Distance EF or C dash gives you the distance traveled by the balloon. Now you see, class, very carefully from the figure. AB is 1.2 meters. AB is 1.2 meters. Then DE also will be 1.2 meters. Similarly, this FD dash also will be 1.2 meters. Opposite sides of a rectangle are equal, right? AB is equal to DE, which is also equal to D dash F. Why? Opposite sides of a rectangle are equal. Now, in that case, listen to me very carefully. In that case, what is the height of the balloon from the ground? Height of the balloon from the ground, CD, is 88.2 meters, right? Okay. And this distance DE, is 1.2 meters. This distance DE is 1.2 meters. Then how are you going to find out CE? How do you find out CE? How do you find out the remaining height CE? From the total height CD, we subtract DE. We subtract DE. That is 88.2 meters minus 1.2 meters, which is equal to 87.0 meters. So 87 meters. You have to note this down, okay? You have to start your answer with this. All right? Immediately after you draw the figure, you need to start writing this one. you need to write this as well. AB is equal to DE, which is also equal to D dash F. Why? Opposite sides of a rectangle are equal. Now, we know that CD, the full length, height of the balloon from the ground, is 88.2 meters. DE and AB are equal, so DE is 1.2 meters. So the remaining height CE. Okay. From full height CD, you subtract DE. Then we get CE to be 87 meters. Similarly, C dash F. C dash F will be also 87 meters. Alright, class. Are you following that? CE is 87 meters. Similarly, you do the same procedure here. Then C dash F will also be equal to 87 meters. Is it clear to you? Alright. Someone is commenting that, okay. Okay, so I think everyone is clear, okay? Now, our objective is to find out the distance traveled by the balloon, which in the given figure is represented by CC dash or EF. So let CC dash, which is also equal to EF, be the distance traveled by the balloon. Traveled by the balloon. Okay. That means I want to find out CC dash or EF. Now, class, can you tell me how many right triangles are included in this figure? Look very carefully. And you tell me how many right triangles are associated in the given figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 options, 1 to 10. Everyone is saying 2. Okay, thank you. Thank you, students, for the comments. Okay, enough. 2. Okay, it's 2. One is AEC. The smaller one, AEC. AEC. In AEC, the angle is 60 degree. Angle is theta is 60 degree. Okay. For this right triangle AEC, the angle theta is equal to 60 degree. And there is another right triangle AFC dash. In the bigger right triangle AFC dash, this angle theta is 30 degree. All right. For the right triangle AEC, angle theta is 60. And for this smaller one, the angle theta is 30 degree. For this bigger one, I mean. For this right triangle AEC, itu right triangle apa tuh? Itu angle 60. And for this right triangle AC dash F, angle is 30 degree. All right? Okay. So in right triangle AEC, for this smaller right triangle, angle is bigger, 60 degree. So tan theta, 60. Tan theta is 60. Tan theta means opposite side upon the adjacent side. Opposite side is your CE, adjacent side is your AE. Tan 60 degree, we know that it is equal to square root of 3. CE is 87 meters, AE is unknown. So if you cross multiply, root 3 times AE would be equal to 87 meters. In that case, your AE would be 87 upon square root of 3. Do not rationalize now, okay? We will rationalize when we are about to calculate the final answer. Only when we start calculating the final answer, we'll rationalize. Otherwise, you'll make a trouble over here, okay? If you rationalize now, you're going to make a trouble over here, so do not do that. Now let's go for the other right triangle. We have the bigger right triangle here, AC dash F, with angle theta given to be 30 degrees. In right triangle AC dash F, tan theta, which is given to be 30 degrees. Tan theta means side opposite to your angle theta. For this right triangle, AC dash F, the side opposite to your angle theta is C dash F. Very clear in the figure, okay? C dash F. C dash F upon the adjacent side. The adjacent to this angle 30 degree would be AF, the full length AF. Tan 30 degree is 1 upon square root of 3. C dash F we have calculated, which is 87 meters. AF is unknown. So you cross multiply. If you cross multiply, AF would be equal to 87 times square root of 3. So we have calculated AF as well. Our objective is to find out the distance traveled by the balloon, which is CC dash or EF. Therefore, distance traveled by the balloon, CC dash or EF. How do we calculate EF? How do we calculate EF? EF is this distance, EF is this distance. How do we calculate EF? From AF, from the total length AF, we subtract AE. Itulah total distance AF pra na. Itu total distance AF pra. AE part to subtract kurile. EF pa ulo na. Ano no hay? Oh, sadigan. AF. We have calculated AF, which is 87 square root of 3 meters. Minus AE. Your AE is 87 upon square root of 3. We cannot subtract this one, but what we can do is we can take LCM. Oh, we can take LCM, yes, correct. Or else we can take common. What is common here? 87 is common, okay? From both the terms, 87 is common. Root 3 is not common. Here root 3 is in the numerator. Here square root of 3 is in the denominator. So square root of 3 is not common, okay? But 87 is common. So if we take 87 as common, then we have square root of 3 from the first term. From the second term, 1 upon square root of 3. Now we can solve the terms inside this parenthesis. Okay? How are we going to solve this one? CC dash is equal to 87, and then you take LCM inside the parenthesis. LCM of 1 and square root of 3 is square root of 3. If the denominator is 1, LCM will always multiply the numerator. Square root of 3 times square root of 3 is 3. Minus, if the LCM and the denominator are equal, they will cancel out each other, and we have 1 in the numerator. Alright, class? So this is 87 times 3 minus 1 is 2 upon square root of 3 meters. 87, 2 times 2, 7 times is 14, 2, 8 times is 16, 17 upon square root of 3 meters. Now in the denominator, we have square root of 3, which is irrational. In the denominator, we are never supposed to have an irrational, okay? Like square root of 3, square root of 2, square root of 5. So our only option is to rationalize the denominator. So we're rationalizing the denominator. Then what we have is 174 times square root of 3 upon square root of 3 times square root of 3 will be 3. So 3 5 times is 15, or 3 5 times is 15, 3 8 times is 24. So the distance traveled by the balloon is 58 square root of 3 meters, which is your final answer. 58 square root of 3 meters. So the required distance, okay, traveled by the balloon. The distance traveled by the balloon, CC dash. C is the final position, initial position. C dash is the final position. Okay, so this distance, you see that? Distance traveled by the beam. 58 square root of 3. Okay, one of the most difficult question here, okay, because you have to do so many adjustments with the figure, and then after obtaining the result also you need to rationalize and keep the things at the proper place, okay. It is the difficult part of this question. So you can take some time, okay, copying this down. All right. So okay, so done. All right then, we shall go for the next question. That is question number 15. We have only two more questions. Leaving out these two questions for tomorrow's class, I'm going to give you an assignment now. A classwork, not an assignment, a classwork to perform. I'll just give you a simple question, and you are supposed to find out the solution right now, right here, right now. All right? Given limited time will be 10 minutes, and we will see who gets the correct answer first. Okay? I'll give you a very easy question. Okay. Not from your textbook, okay? Not from your textbook. Let me just see a question which you can do it. Okay. Okay, I'm going to write down the question. This question may be included in your examples, so instead of that, let me give you another short one. Similarly to what we have done. Okay, similarly to what we have done. So the question says, the angle of depression, the angle of depression of the top and bottom of the top and bottom of a 9-meter high building, of a 9-meter high building, 9-meter high building from the top of a tower, from the top of a tower, from the top of a tower, are 30 degrees and 60 degrees respectively. Full stop. Find the height of the tower. Find the height of the tower and the distance between the building and the tower. And the distance between the building and tau. Okay, your time starts now. Let's see who can answer this first correctly. Okay, you have limited time. You have 5 minutes for solving this question. With in these 5 minutes, if anyone cannot give a correct answer, then would be considered as the champion of class 10 in mathematics. So is there anyone who wants to be the champ? Plus, are we clear with the questions? Are we clear with the questions? If anyone is not clear with the questions, you can please comment on the chat, then I can make it things more clear. You can take the help of your textbooks, your notebooks, okay, your Facebook, anything that you like. If anyone not clear with the question, you can please comment. I can make things more clear to you. You have 3 more minutes to 10. Okay. Anyone who has got any answers can please comment on the chat. So I have one comment. The angle of the top and bottom. Oh, very good, very good. Who is this one? Cinderella commented that yes, yes, yes. Distance between the building and the tower is 7.8 meters, 7.794 approximately. And the height of the tower is 13.5 meters. Very good. Okay, who is this boy? The first reply was from Cinderella. Okay, so Cinderella, congratulations. So you are considered as the champion of mathematics in today's class. Okay, every day we'll have new champions. So do not worry, every time after we discuss, I will be giving you some classwork to work out. Accordingly, we'll have champions. Okay, so congratulations. I think that's all for today's class, all right? Okay, you study hard and we'll be continuing with the same chapter tomorrow. So you can log out now.